Hello everyone. Welcome back to the course of Software Analysis and Design Patterns. This video is brought to you by Newton's Group of Institutions in association with Redefined Solutions. This is Yegireddy from the Department of Computer Science and Engineering. And in this video, we will discuss about design patterns. Designing object-oriented software is hard, and designing reusable object-oriented software is even harder. We must find appropriate objects, factor them into classes, and the right granularity, define the class interface and inheritance hierarchies, and establish key relationship among them. So our design should be specific to the problem at hand, but also general enough to address the future problems and requirement. We would also want to avoid redesigning, or at least we need to minimize it. So the experienced object-oriented designers will tell us that the reusable and flexible design is difficult, if not impossible, to get right the first time. So before a design is finished, they usually try to reuse it several times, modify it each time, and they experience object-oriented designers to make good designs, which mean that while new designers overcome this by options that are available and tend to fall back on a non-object oriented techniques they have used before. So it takes a lot of time for beginners to learn. With good object oriented design is always about recurring patterns of classes and communicating objects in many object oriented systems. And these patterns solve specific design problems and make object oriented designs more flexible, elegant, and ultimately reusable. So they help the designers reuse successful designs by basing the new design on prior experiences. So here a designer who is familiar with such patterns can apply them immediately to design the problem without having to rediscover them. So here the design patterns makes it easier to reuse a successful design and architectures, expressing previous proven techniques as a design patterns, which makes them more accessible to the developers of the new system. So here we can say design patterns helps us choose the design alternatives that makes a system reusable and avoid alternatives that compromise the reusability. So here design patterns can even improve the documentation and maintenance of the existing system. So here, by finishing an explicit specification of the classes and object interactions and their underlying intent. So here, we need to put simply the design patterns which help to design and get a design right faster. Now, let us see what is a design pattern. Christopher Alexander says that each pattern describes a problem which occurs over and over again in our environment, and then describe the core of the solution to the problem in such a way that we can use the solution a million times over without ever doing it in the same way twice. So what he says is true about the object-oriented design patterns. Our solutions are expressed in terms of objects and interfaces, but at the core of both kinds of patterns is a solution to a problem in a context. So here, let us see the relation between object-oriented programming and design patterns. Here, object-oriented programming OOP is cooking, and design patterns DP is a recipe. So here it is something like playing with puzzles. So when we are given a puzzle game for the first time, what we will do? We would try different combinations and take more time to get the right solution for that particular puzzle. But when we play the same game for the second time, we would get the solution in less amount of time, and the third time even less amount of time. So similarly, the design patterns, they help us to create the software designs faster and which are reusable. So here design patterns are repeatable, reusable solutions to commonly occur problems in a certain context in software designing. Now here the design patterns has four essential elements. The first one is the pattern name. So here the pattern name is a handle we can use to describe the design problems and its solutions and the consequence in a word or two. So here naming a pattern immediately increases our design vocabulary and it lets us design at a higher level of abstractions, having a vocabulary of patterns which let us talk about them with our colleagues in our documentation, even to ourselves. So it makes easier to think about the design and communicate them at the trade-off to the others. So finding good names has been one of the hardest part of developing our catalog. And the second element is the problem. So here the problem describes when to apply the pattern. It explains the problem and its context. It might describe the specific design problem such as how to represent the algorithms as objects. And it might describe the classes or object structures that are systematic on the flexible or inflexible design. Sometimes the problems will include the list of conditions that must be met before it makes sense to apply them pattern. Now coming to the third one, that is a solution. So here the solution describes the elements that make up the design and their relationships, responsibilities and collaborations. Here the solution does not describe a particular concrete design or implementation because the pattern is like a template that can be applied in many different solutions. Now the fourth one is consequences. So here the consequences are the results and the trade-offs of applying the pattern. Although the consequences are often unvoiced with when we design the decisions, so they are critical for evaluating the design alternatives and for understanding the cost and benefit of applying the pattern. So here the consequences for the software often concern the space and time trade-offs. So here they may address the language and implementation issues as well. The consequences of a pattern includes its impact on the system, which is flexible, extensibility or portability. So here a design pattern names and abstractions and identifies the key aspects of the common design structure that make it useful for creating the reusable object oriented design. So the design pattern identifies the participating classes and instances, their roles and their collaborations, and the distribution of the responsibility. So each design pattern focuses on a particular object-oriented design problem to or issues. So it describes when it applies, whether it can be applied in a view of other design constraints and the consequences and the trade-offs of its use. Now, let us see the design pattern in a small tail MVC. So here, model view controller or MVC as its popularity called as MVC is a software design pattern for developing web applications. So here the model view controller MVC trade of classes is used to build the user interfaces in the Smalltalk AT. A model view controller pattern is made up of the following three patterns. So here the model is an application object. The view is a screen presentation and the controller which defines the ways the user interface reacts to the user inputs. So MVC which decouples them into increased flexibility and reuse, and MVC decouples views and models by establishing a subscribe or notify protocol between them. So here a view must ensure that its appearance reflects the state of the model. Whenever the model data changes, the model notifies the views that depend on it. In response, each view gets an appropriate opportunity to update itself. So here, this approach lets us attach multiple views to the model to provide different presentations. And MVC, which is popular as it isolates the application logic from the user interface layers, and they support the separation of concerns. So here, the controller receives all the requests for the applications and work with the model to prepare any data needed by the view. So here, the view that is being uses the data that is being prepared by the controller to generate the final presentable response. So here the MVC abstraction can be graphically represented like the image that is being shown here. So we can also create a new views for the model without rewriting it. So clearly the following diagram shows a model of 3 views. The model contains some data values, and the views define the spreadsheets, histograms, and pie charts that display these data in various ways. And the model communicates with its view when its value changes. And the view communicates with the model to access these values. Now, coming to describing the design patterns, how do we describe the design pattern? Of course, graphical notations which are important and useful are not sufficient. They simply capture the end product of the design process as a relationship between classes and objects. So, to reuse the design, we must also record the decisions, alternatives, and trade-offs that lead to it. So here the template lends a uniform structure to the information, making design patterns easier to learn, compare, and use. So here, pattern name and classification. Here the pattern name which conveys the essence of the pattern briefly. A good name is vital because it will become part of your design vocabulary, and the pattern classification that reflects the scheme we used. The intent is a start statement that answers the questions. What does the design pattern do, and what is its rationale and intent? What particular design issues or problems that does it address? So here we also know this as a kit. So here, coming to motivations, a scenario that illustrates the design problems and how the classes and object structure in the pattern solve the problem. So here, this scenario will help us understanding the more abstract descriptions of the pattern that follows it. Coming to applicability, here, what are the situations in which the design patterns can be applied? What are the examples of poor design that the pattern can address, and how can we recognize these situations? So these are the questions that what we need to do when we are applying it. Coming to the structure, a structure is nothing but it is a group graphical representation of the classes in the pattern that is being using a notation based on the object oriented modeling techniques, OMT. So we also use interaction diagrams to illustrate the sequence of requests and collaboration between the objects. Now we need to see participants. So they are the classes or objects participating in the design patterns and their responsibilities. Now coming to collaborations, here in collaborations we see how the participants collaborate to carry out their responsibility. And coming to the consequences, here we need to identify how does the pattern supports its objectives, and what are the trade-offs and results of using the pattern, and what aspects of the system structure does it let us vary independently. Now coming to implementation, here what pitfalls, hints, and techniques we should be aware of and when implementing the pattern. So are these language specific issues can be solved? So these are the questions that what we need to understand while implementing. Coming to the sample code, the code fragments that illustrates how we might implement the patterns in C++, C++ or Smalltalk or any other languages. And here the known uses is example of the pattern found in the real system. So here we include at least two examples from different domains. And coming to the related patterns, what design patterns are closely related to this one, and what are important differences, and with which other patterns should this one be used. So all these things we need to discuss when coming to the related patterns. So here these are the different templates that leads a uniform structure to the information, making decision patterns easier to learn, compare, and use. So these are the 12 different templates what we need to understand while when we are designing a design patterns. That's all for now. Thank you all. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. Thanks for listening with great patience.